Okay, so in previous lecture, we saw the sun and earth geometry, the radiation received by one particular location on the surface. It is depends upon its latitude and its particular location, and also it's having some different angles. Means consider this one is the surface, this particular surface. I will just show you. This particular surface, if we consider this one is the collector, solar collector, because solar energy, as we know, the particular Earth surface will receive the 1350 watts of solar energy per meter square. Okay, so it is depends upon the area. Means 1 meter square area will receive the 1300, nearly 1300 watts of energy per second if the sky is totally clear. Okay, so it is also depends upon the weather conditions. But if we consider the sky is particularly clear, in that case, the radiation received by that particular surface, it is also depends upon the different types of the angles. Because we saw in the heat transfer, if there is one horizontal surface, okay, and the radiation is impacted or incident on that horizontal surface, making 90-degree angle, okay, or in the normal direction. In that case, this intensity of the radiation which is received by the surface, it will be the maximum intensity. Means it will be the maximum efficiency IR. If these particular surfaces are making some angle or the radiation received by that particular surface, it is having some angle which is less than the 90 degree, or if it is not perpendicular, then the intensity of the radiation is going to be decreases. So that is the characteristics of radiation and the transfer of the energy. So this intensity of the inclined ray and the intensity of the normal ray, it is going to be different. The normal ray will having maximum intensity, whereas this inclined ray will having minimum or the less intensity than the normal ray. So how we can compare or how we can relate these two intensities? For that we are using cosine law, means the intensity of the inclined radiation is equal to the maximum intensity into cos of theta, cos of theta. Okay, so theta means what? It is the angle between the normal and that incident ray. Okay, so these particular angles here you can see if you tilted this particular surface, the angle between the incident radiation and the normal of that particular surface, it is called as the theta. Okay, or it is also called as the incident angle. So the intensity is depends upon the intensity, this particular incident angle. Okay, so for that you must know what is the incident angle at a particular location if you want to analyze the performance of that particular solar collector. Okay, so in that case we are using different angles, different types of the angles. We are using altitude, we are using surface azimuth angle, solar azimuth angles, then the different types of the incident angle, zenith angle, etc. So all those angles are most important to find out the intensity of the radiation. And after find out the intensity of the radiation, you can calculate the particular analyze its performance of the solar collector. Now this incident solar energy has been used, or we can absorb that energy by using the solar collector, because on particular this solar radiation is incident on the earth surface, right? Now that energy we have to use, and to use that energy, we are using different devices like the flat plate collector, evacuated tube collector, concentrating collectors. Then we can use the PV cells to convert that radiation energy into the electricity, etc. So that the one application is that solar collector, and these are the wide application in most of the devices, or in most of the applications we are using the flat plate collectors, concentrating solar collectors to concentrate or the absorb the solar radiation. Okay, now the intensity of the radiation is depends upon weather conditions as well as the location of that collector, right? Now to absorb more and more energy, we have to use this flat plate type of the collectors and other type of the collectors. Now these are the applications, or these are the actual devices which are used to absorb solar radiation which is received by the Earth's surface. Okay. So now in that case, in that we are going to first study the flat plate collector. Now you will see this is the construction of the flat plate collector. You already saw these type of flat plate collectors on around you for the water heating purpose, or for any other purposes like the drying of the food, or the drying of the grains, or in the food industry, etc. Sometimes these collectors are also used to heat up the air, and that heated air we can use for any type of applications. Particularly, that heated air is used to dry out the grains. Okay, so these flat plate collectors are mostly used, widely used for particularly for the water heating purposes. Okay, now but this particular technology is a old one. Okay, now nowadays we are using the evacuated tube type of collectors, that also we are going to see. So first of all, the flat plate collector, you will see the construction. There is a one box. Okay, and inside the box there are the tubes, and whatever the working fluid will be there, that will be passing through these particular tubes. Okay, now to these particular tubes, one absorber plate has been attached. This particular plate you are saying, it is the absorber plate. Okay, because if we only use the tube, the amount of radiation directly incident on that tube is very small. Okay, so in that case, to increase the amount of radiation which is or the increase the heat transfer, we are using the this particular flat black absorber plate. And on that you can see there are two transparent screens, or the glass covers we are going to install. Okay, now this is a simple construction of the flat plate collector. Now how it is working? Okay, so the first of all, the objective of using the flat plate collector, if we used for the water heating purpose, in that case we required hot water, right? So for that, what we do, we are passing that hot water through these tubes. Okay, and the radiation will be incident on that tube, and as radiation will be incident on the tube, water will absorb that heat which is coming from the solar radiation, and it will heat up. Okay, now if we just uh, plot one tube. Okay, or if you want to just put this particular water tube only, in that case the surface area of the tube is very less. Okay, surface area is very less. So in that case, the heat absorbed by that particular plate, particular tube, is very less. Okay, so to increase or enhance that absorb or the amount of heat absorbed that by that particular tube, what we do, we just added the fin or one sheet to the sides of the plate. Okay, sorry, sides of the tube. So consider this middle is the tube, and on the sides of the tube we are attaching the sheet. Okay, sheet, metallic sheet particularly, which is having higher thermal conductivity. So in that case, what will happen, the amount of radiation incident on that tube or on that particular sheet, that energy, that radiation energy has been transferred to the liquid or the water passing through that particular tube. So whenever we attach these sheets to the to that, or sometimes it is also called as a film, right? So it is very similar to the film. So here, what will happen? The radiation will incident on that sheet or the film, and that energy will be transferred through the conduction to that particular liquid which is flowing through that particular tube. Okay, so whenever we attach these sheets or the fins, we are increasing the amount of radiation incident on that particular collector. Okay, so it will also increases the performance of the collector. It will increases the temperature of that flowing fluid. Okay, so these are called as a absorber plate. Now, why it is called already painted into the black color? Because as we know, the characteristics of the black cover or the black body we know, right? So if any particular black body is there, that body will absorb maximum radiation. Okay, because you already studied the characteristics of the surface, radiative characteristics of the surfaces, and the particular bodies. So in the case of black body, consider one black body is there. If radiation incident on that black body, the black body will absorb 100% or nearly 99% of the radiation. Okay, so that's why to absorb maximum incident radiation, because when the radiation will incident on it, if it is not painted in the black color, in that case, some part of that radiation will get reflected, right? So that will be the loss of energy. So to avoid that, what we do, we are painted these fields or the sheet with the black color, also the tube we are painting in the black color. So it will nearly work as a black body, and whatever the radiation incident on that particular plate and also on the tube, maximum part of that radiation will be absorbed and minimum part will be reflected. So the loss of radiation energy will be less in that case, and because of that, these particular sheets or the plates will be painted by the black color. Okay, so that's why you will see the black color type of the paint on that sheets also on the these particular tubes. Okay, so it will increases the emissive characteristics as well as the absorbent characteristics, and that will cause improvement in the uh, performance of the flat plate collectors. Now, what are the materials? Okay, what are the materials we are using? Mostly the material or the metal which is having higher thermal conductivity, it has been used because when the radiation is incident on the surface of that tube or the surface of this particular sheets or the film, what will happen? It will transfer from this tube surface, okay, to the fluid which is flowing inside the tube. Now that heat transfer, it is carried out through the conduction mode. Okay, it is carried out through the conduction mode. So we already know for the higher conductivity, higher conduction, we require higher conductivity, right? So the material which is used, construction material is used in these flat plate collectors are mostly the metals which is having higher thermal conductivity. Now we know the gold is having highest thermal conductivity. Also, silver is also having more higher thermal conductivity, but we cannot use those materials because those are the precious materials, and the cost of those materials is very high. So instead of those gold and silver, we are using the copper. Okay, sometimes we are using copper and sometimes we are using aluminum also. So mostly we are preferring the copper because uh, uh, the thermal conductivity of the copper is very high. Okay, and also the weight ratio and all those factors characteristics are very suitable to construct the flat plate collector. So the construction material, generally the copper tubes are used, and those this particular foil or the sheet is also it is of the copper. We are just painted this copper in the black color. Okay, so this is regarding the construction of the tubes and this particular flat. Now you will see there is a thermal insulation is there on the bottom side of this particular tube to avoid any type of energy loss to the atmosphere. Okay, and also there is a transparent screens or the glass covers has been installed. Now why those glass covers are installed? First of all, when the radiation is incident, it will transfer through this particular glass cover. Okay, now if we consider this particular surface as a black body, okay, but it in practice it is not work as 100% as a black body. It is near to the black body, but some part of the radiation still reflected back from that particular surface. Okay, now that reflected radiation or the rays is again going to be incident on the inner surface of this glass cover, and those reflected rays is again reflected back onto this particular sheet of the tube. Okay, so this transparent screen will act as a, or it will store the radiation energy. It will trap the radiation energy inside this box. Okay, so that's why this transparent cover, particularly the glass cover, is used. Okay, and whenever the radiation coming from the sun, it is mostly it is in the it is having low wavelength radiation. Okay, so it will easily transfer through this transparent screen. But when it's incident on this on the tube, and when it back reflected back, in that case, these radiation, whatever the radiation reflected from the surface, it is having higher wavelength. Okay, so in that case, these higher wavelength radiation cannot cross the transparent screen or the glass cover. That is the characteristics of that type of the radiation. So that's why we are using the glass transparent cover. It will trap the energy inside the box, and it will also going to improve your efficiency or the performance of the flat plate collector. So that's how it is working. You can also refer this particular effect due to the transparent screen to the global warming effect or greenhouse effect, particularly the greenhouse effect. Similar to the greenhouse effect, the effect will be happen inside the box, and then because of that, the temperature outside these particular tubes is again higher than the atmospheric temperature. Okay, so that these are the construction features of the flat plate collector. That's how it is working. Okay, so the main component you saw black surface, glazing covers, and the tubes, support structures, insulation covering, etc. You will see these types of the tubes and the sheets which are connected to that particular tubes. Those are particularly painted in the black color, so you will get or you will enhance the performance of the flat plate collector. Now, this flat plate collector system will normally operate in the range of 30 to 80 in the previous some cases. In the advanced collectors, the temperature will be again we can achieve the temperature is up to 100 degree or more than the 100 degree in sometimes in some cases. Okay, so due to this introduction of the selective coating, which is on this particular plate, you will see the stagnant fluid temperature in the flat plate collector, it has been reached up to the 200 degrees centigrade. So we are able to increase the temperature of this particular water which is passing through this particular tube by using the different methods, by using the different systems. Okay. Now the these hot water we can use for many applications. Okay, it is depends upon you for which application you are going to use that water. Sometimes it is used domestically. Sometimes it is used for many other processes. In the food industry also we are using. Sometimes it is used. Okay, so this is a flat plate collector. This is particularly the old technique. Okay, because in many applications you already saw this type of the collectors are there. Those are just mounted, which is having some angle to the ground. Okay, and it is generally in the northern hemisphere it is directed toward the south, and in the case of southern hemisphere, it is directed toward the north. So that is because of the incident angle and all those geometrical relationship between sun and earth. Okay, now this is the actual flat plate collector system. You will see these are the flat plate system. Okay, this is the flat plate collector, and whatever the heated water is there, it has been collected into this particular tank. Okay, now the cold water and hot water both are the connected or the collected in this particular tank. First of all, what will happen? The cold water has been provided from the bottom side. Okay, so here from here, cold water has been provided. Now, as cold water will enter, it will pass through this particular tubes. As it is heated, the density of this cold water is get reduced. Okay, it will heated, and because of the increment in temperature, density will reduces, and because of that, it will as density is reduces, it will move in the upside because its weight is going to be reduced. So it will moving into upper side. The natural convection will happen. Okay, so as it passes up to this particular height, it will get heated and it is again stored into this particular storage tank. Okay, so that's how the flat plate collector will work. Now there are different types of the constructions or the designs are available to improve the efficiency or the performance of the flat plate collector. You will see these are the various types of the designs of the collectors, the tube shapes, and also the placement of the tube or the geometry of that cover, geometry of the schemes and the tubes are going to be changed. And by using those combinations, we can actually be more and more efficient type of the design of the flat plate collector. So you can see here, this is the simple having circular tubes, and this absorbing plate has been installed on the upside uh, in front of that particular tubes. Okay, Now here the shape of the tubes are various trapezoidal shape is there, and the fins are connected on the sides. You can see here. Similarly, in the design B, you will see the fins are connected on the sides, not on the top of this particular tubes. Okay, so tubes are the circular, but fins are connected in the sidelines of the tubes. Similarly, here the rectangular tubes you can see. Okay, the water will be flow through this rectangular tube, and the particular absorbing plate has been installed below this particular tube. Okay, so these are the different designs of the collectors, flat plate collectors. Generally, the circular tubes having the absorbing plate on that particular circular tubes or the sides of the circular tubes is mostly used. So this type of design is mostly used. Okay, so some advantages of the flat plate collectors. This is easy to manufacture. It is having very low construction cost. We can easily install the flat plate collector. Now the maintenance cost is also less than the other type of the collector, like the evacuated tube type of collectors. It will collect both beam and diffuse radiation. Okay, as we know, beam radiation means it is the direct type of radiation. Means when radiation directly incident on the surface, it is called as the beam radiation. And diffuse radiation means what? Solar radiation, first of all, incident on the other object, and it is reflected from that other object and then incident on that particular tube. It is called as a diffuse radiation. So this flat plate collector can collect beam radiation as well as the diffuse radiation. We can permanently fix that particular construction, that particular device, and there will be no any tracking device is required, or the tracking equipment is required in the flat plate collector, and it is having very less maintenance. Okay, that is important because the costing and the construction cost is very less in the case of flat plate collector, so the maintenance is also going to be less. Now, these flat plate collectors is involve one liquid or the air heat transfer medium, right? Because the medium which is transfer, or the fluid which is transferring through this particular tubes, it will actually absorb that solar energy. Okay, actually absorb the heat, right? So that the particular liquid which is used in this in the tubes or the solar flat collectors, we have to study its characteristics also. Generally, we are mostly using the water as a transparent fluid or transport fluid, or the fluids in the collectors. But in many cases, we can use the air in that particular tubes, or in many places we are using phase change material. Okay, so there are some flat plate collectors are there where we can uh, use the air as a working fluid, or we can also use the phase change material. Okay, so as a working fluid, but commonly we are using the water because of its characteristics. First of all, it is uh, uh, available, easily available. Okay, it is have a relatively high volumetric heat capacity. Its characteristics or its thermophysical properties are very good, which are very suitable for this particular application. It is a particularly incompressible fluid because we cannot compress the liquid water, and it is having very high mass density. So, which will allows using small tubes and pipes for the transportation. So, it will absorb more and more energy. So, because of these thermophysical properties, we are mostly using water as a working fluid. So this is regarding the flat plate collector. So particularly this is the old technique. The efficiency we are getting in this particular flat plate collector, it is depends upon many factors, but it is the old technique. Nowadays, in most of the cases, or for the water heating purposes, we are using evacuated tube collector. Okay, so the main objective is the same. We have to heat up the water by using the solar radiation or by using the solar energy, but here the construction of the collector is going to be changed. Instead of the simple tube, instead of this simple tube, and which is having also having the seam, we are using evacuated tube in this particular collector. Okay, now evacuated tube, why we are calling it as a evacuated tube? For that, when we saw the construction of the evacuated tube, there are the two tubes. Okay, there are two tubes, one tube inside other tube. So two concentric tubes are there. You can see here. This one is the tube number one, and this one inner side it is the tube number two. So two concentric tubes we are taking. Okay, and these two tubes are sealed. Their ends are just sealed. On the other side, you will see the curved tube. So one tube is inside the other tube, and the three end will be just sealed. And inside this one, we are producing the vacuum. Okay, so the space which is in between these two tubes means this particular space, we are removing all the air which is present inside this space, and the vacuum has been maintained. Okay, vacuum has been maintained. We are construct this evacuated tube like this one. Okay, and after that what will happen? This tube, whatever the water, first of all, which is transferred through this inner tube, this particular tube, that is tube number two. Okay, when the water transfer through this, first of all, what will happen? The cold water will transfer from the bottom side of the tube, which is the inner side of tube. So water will be transferred first of all. This cool water having high density, so it will automatically it will go to the bottom of the tube. Okay, when it reaches here, because of the solar radiation, it will heat up. Okay, and because of the heat up, what will happen? The density of water is going to be decreases. As density decreases, it will goes on upper side because of the natural convection. So that's how the flow of water will carried out inside the evacuated tube. Okay, because the natural convection will happen, or sometimes this flow is also referred as a thermosiphon. Okay, siphon flow or the siphon tube you already know in the fluid mechanics. Similarly, this particular flow is sometimes called as a thermosiphon flow. Okay, so this natural convection, through that natural convection, this water will heated up. Now, why we have to use the evacuated tube collector? Because the efficiency, overall efficiency of the evacuated tube collector is much more than the flat plate collector. How it is much more? Because as we know, the radiation will first of all incident on the outer surface of the tube number one. Okay, then it will pass through this particular tube and incident on the water which is flowing inside the inner tube. Okay, now it will going to water will going to be absorb the some part of that radiation. Now some part of that radiation it is going to be reflected from the outer surface of inner tube. Okay, so that radiation is completely lost. If it doesn't use this particular phenomena, it will completely lost. Okay, now what will happen when it's again reflected from the inner tube outer surface? It will incident on the inner surface of the outer tube. Okay, and it will just get again reflected, and again it will be absorbed by the water. So whatever the loss will be there, that loss is going to be decreased. Okay, that loss is going to be decreases in this evacuated tube collector. And because of there is a vacuum present in between these two tubes, the loss of the radiation or loss because of the heat transfer, it is very less. Okay, generally negligible loss. Okay, whenever we using this flat plate collector, you can see here, whenever we using the flat plate collector in the during the day, you will receive the radiation, and the heat will be the water will be heated. But in the case of nights, what will happen? The temperature of water which is present in this tube is high. Okay, and the temperature outside or the temperature of the atmosphere is less. So in that case, what will happen? The radiation from this tube, okay, this tube will radiate radiation from the heated water to the atmosphere in the during night, and because of that what will happen? The heat has been lost because of the radiation. Okay, so to because of that what will happen? The overall efficiency of this collector is less. So to avoid that, we are using evacuated tube type of collector. So in that case what will happen is, during the night time, when radiation or the heat loss due to the heat transfer, when the radiation is rejected or the uh, uh, emitted by the heated water, it will incidence on the inner surface, and this inner surface is highly reflective. Okay, it is highly reflective, so it will reflect back that radiation to the water. So practically there is no any heat loss in this particular case. Okay. Also, the heat loss due to the conduction and convection is a zero because there is a vacuum in between these two pipes. So the heat loss in this evacuated tube type of collector is very less or nearly negligible, and that's why the efficiency is very high in the case of evacuated tube collector. Okay, so that's why in today's case, or in today's years, or in today's applications, we are mostly using evacuated tube type of a collector. Okay, so that is the importance of the evacuated tube collector. It is also depends upon how much of energy we will going to absorb or the take. It is totally depends upon the area. Okay, how much numbers of pipes you are installed and all those things. You will see this type of the collectors. These are the tubes. These are the different evacuated tubes. Okay, you will see. So you can see there is no any box required is there. Okay, only tubes are there, and the support structure is there, and then this particular uh, uh, storage. Okay, so these type of the water heaters are mostly used nowadays in the domestic applications. The efficiency is very high. You will get the very high temperature in these types of the water heaters. Okay, even the temperature here it is goes beyond the 100 degrees centigrade. Okay, so you can achieve the 100 degrees centigrade, more than the 100 degrees centigrade in this type of the collectors. Okay, so these are the main two types of the collectors. You will see different types of the other type of plate collectors are there, where we are joining another systems or the assemblies to that collector to improve its performance. Okay, so that's it. We will going to stop here. These two type of collectors are important. Those are mostly used, widely used in many applications, and you can achieve the temperature near about 100 degrees centigrade by using those types of the collectors. Okay, so the remaining collectors like the parabolic collectors and all those collectors we are going to see in the coming lecture. Okay, so we will stop here. If anybody have any doubt, you can ask now. Otherwise, we will stop here. The